Welcome students. Today we will be studying Python programming language. Okay. So what is Python? Python is a multi-paradigm, high-level, general-purpose language. Okay. So let us try to see what is the meaning of multi-paradigm, high-level, and a general-purpose language. Why is it called a multi-paradigm? Because it supports various programming styles. For example, it supports functional programming, supports structured or modular programming, and it supports object-oriented programming as well. Functional programming is what? All variables are in global area of memory, right? And multiple functions share that memory. Okay, so that is functional programming. Compared to functional, what is structured programming, right? In structured programming, we also have functions, so functions are there. But there is both local and global areas of memory location, right? So functions will have some memory which is local to them, and then there are global areas that everyone can share. And then finally, what is object-oriented programming? Okay, so in object-oriented programming, this is what we called data-centered approach. So program is divided in terms of objects rather than function. Okay, both in functional and structured programming, what we do, we create functions. What is a function? A function is nothing, so we have a function. It takes some input and it produces certain output, right? And my program can be a bunch of functions. So I have a program, so suppose this is my program, and I can have a function 1, function 2, function 3, and so on, right? So I give some, so there is this global area of memory, global memory, some input is coming here. So all of these functions can access this global area of memory, and they produce output in this global area, and we produce the final output of the program. So this is my functional programming. Whereas in structured programming, I have this function, and this is its memory area which is local to it. Then I have another function, and it has its own memory area, and then we also have a global memory. This is my structured or modular. Okay. Whereas when we come to object-oriented design, so we create certain objects. So this is my object 1. So this is divided into two parts. I will have multiple functions, and these are my attributes, and these are my functions that only interact with those attributes. So I can have another object, object 2, and so on. And there may be some interactions between those objects. So object-oriented design caters to the general structure that we see in the world around us. So for example, if we consider a table fan, right? A table fan has properties like its manufacturer, color, wattage, etc. And it has functions like turn on or off. It has functions like speed, change, etc. Right? So anything we see around us has attributes and functions. So in object-oriented design, rather than focusing on functions working on either global area or some local memory and global memory, we see our program as collection of objects. Each object has some attributes, and each object has some methods in it, and those methods work on those attributes, and further these objects can interact amongst themselves. So we will consider about object-oriented programming later. First of all, let us get introduced to Python programming language. So Python is multi-paradigm because it supports different types of programming styles. Now, why a high-level language? Because it is an interpreted language. So the syntax is almost English-like syntax. Okay, so and, or, not, if, else, for, while. So these are the kind of keywords used inside Python. Print, input. So just by looking at the program, you can kind of understand what that means. And why it is called a general purpose language? It's because it is used for many applications. Okay, and we'll look into that a little later, what are the different kind of applications Python is used in. So now let us see a little bit of more characteristics of each of these features. We discussed already why it is multi-paradigm. Let us discuss why it is called high level, right? As we know from before that a computer understands only zeros and ones, which is the machine language, right? Then there was the assembly language, that is of the form opcode, operand 1, operand 2, and so on. So where rather than using zeros and ones, we give names to operations and addresses of registers. I will not go into detail of registers. We can go into our introduction for C programming language, where we discuss the basic computer architecture. So these are my low level languages. Then comes high level. So they are more programmer friendly languages. Okay, and they came actually with something called a translator. So translator can be a compiler or it can be an interpreter. Okay, so a compiler is, for example, in C language we already discussed. So a compiler takes in the program, so your source code, this is my compiler, and it produces my machine language code, right? Actually it produces the assembly code, and the assembler further produces the object code, which is further linked. But in common parlance we can say that compiler produces directly machine language code from source code, whereas interpreter is something different. So what is an interpreter? Interpreter is a program that reads your source code line by line and executes it. Okay, so it may not convert your program exactly into machine level instructions, but it is going to read your program, try to interpret it, and do the necessary tasks that you are asking it to do. Okay, so it is quite different from a compiler. So while a compiler is converting your program into machine code and then finally your program is running, when you run an interpreted program like Python, the Python program actually is not running. It's the interpreter which is running and which is taking your program step by step, line by line, interpreting it and executing those steps. Okay, we can see more differences in compiler and interpreter in the notes, but basically because the interpreter has to do an additional task of interpreting line by line, it is usually slower than a compiler, but then it provides the benefits that you did not compile your code. So you can take your program on any computer, any architecture, as long as it has that interpreter installed, so you can execute that program. So we can write, say, benefits of interpreter. What are the benefits of interpreter? Number one, portability, right? So that means your Python program can run on any computer or OS as long as the Python interpreter is installed there. Okay. The second benefit of that being interpreted is quick response. So you do not have to wait until entire program is complete, right? So you can run it step by step, okay? So that implies errors can be detected early on, right? You don't have to wait till the entire program compiles and then save the program, compile the program, then see for errors, then debug it. So rather than that, you keep testing your code line by line, and whenever there is an error, you know that there is an error. So that's another benefit of that being interpreted. The third benefit of being interpreted is scripting. So it implies that given that Python has facility to call other programs and operating system commands from within it, so one can easily create scripts that will run without being compiled, right? And scripts are very, very common in shell programming or in system administration. So Python can very well be used for scripting purposes, right? There is something, hash bang syntax, which you can see in our course notes, okay? So that allows us to write a script which is executable. So that means we are not compiling this script. The script is just executes because the Python interpreter is there installed on the machine, and you can do it on Windows, Mac, or Linux, or on any kind of system, okay? What are the disadvantages of Python being an interpreted language? Is the major demerit is that the execution is slow, okay? So line by line your program is being interpreted by the interpreter and then being executed. It's quite different from compiler because there is no optimization, right? The compiler usually optimizes your code to make it run faster, right? So these are some of the demerits of Python being an interpreted language versus a compiled language, okay? So memory management becomes non-trivial, right? So you don't know beforehand how much memory to allocate. Step by step, the program may require any amount of memory, whereas in a compiled program you can at least anticipate the amount of memory. Of course, dynamic memory allocation is a little different. That has to be managed differently. Okay. So now that we understand what is Python, that's a multi-paradigm language, it's high level. Now let us say why it is a general purpose language. So what is the opposite of general? It is specific. So rather than being used for any specific purpose, Python is used for myriad purposes, right? So for example, let us see what all Python is used for these days. So Python is used for web programming, right? So there are frameworks like Django, etc., with a built-in HTTP server, and you can actually serve HTML pages from within Python, okay? So another application can be your system programming. So as we discussed that Python has features for scripting, so we can write operating system level scripts to manage different tasks. So scripting comes handy here. Another is graphical user interfaces or GUIs. So Python has built-in support, or it has third-party or external libraries to support the TK, which is widely supported GUI kit for most operating systems, Mac, Linux, Windows, etc. So we can write graphical user interfaces. Then Python can be used for games. In fact, there are some games written in Python. Well, until recently, mostly 2D games, okay? So 3D or GPU programming is not that much supported, okay? Of course, there are some solutions now and things are changing, okay? Then you can, use as a text-based programs, text editors, etc. You can code your music players or say multimedia in Python, right? Nowadays, Python is very heavily used for scientific and numerical computing. So it has wonderful libraries like, NumPy, Pandas, Scikit, Matplotlib, etc. So that makes it very, very useful for data science applications. Okay, and that's the trend of today. So data science, we can write a trend of today and future. So if you really are looking for a decent or great job, I would say pay attention to data science. So in this semester you have an R course as well. So do learn the concepts. Whatever you can do in R, you can do in Python as well with the help of these libraries. So do understand the statistics principles and all that. So there are many other applications, but we can see how Python can be used for multiple purposes. So therefore it is also called a general purpose programming language. Okay. So now, who invented Python? Okay. So Python was invented by a person named Guido van Rossum. Okay. Back in 1989, so it started, implementation began, and 1991 was first release, okay, and then Python 2 was released in 2000, so that was Python 2, and then Python 3 was released back in 2008, and the latest release right now, which is 2017, is of Python 3.6.1. So gradually it is moving towards 4.0, and there have been a lot of changes. So because Python is open source, that means it is not a proprietary language. So nobody owns it as such, nobody has claims over it, so nobody would charge you money for using Python. So because Python is open source, so it has been going through a lot of changes. So that's one of the disadvantages of using Python, that things may change beyond your expectations. But it is being very, very popular language now. Although, not many people are using it. So if you see in terms of, so if we see like, in terms of this is all the programming languages. So Python may be used by a small fraction right now, but it is spreading. So if we consider Python versus, PHP, Java, C#, etc. So still Python community has to grow, but it is growing rapidly, particularly with these applications in data science. Okay. So Guido van Rossum, he used to work, so he was working at Google from 2005 to 2012, and you can see actually Google is one of the major users of Python. Similarly, since 2013 he is working at Dropbox. So Dropbox is also a major user of Python. So he has kind of introduced Python in these places. So why Python? So it's a weird name. Python is kind of a snake, right? And if you see the major distribution of Python, that's called Anaconda. So I don't know why these weird names. Anaconda is the biggest Python in Africa that you can find it. So why it is called Python? Because this person, because Rossum was fan of a British comedian, and his name was Monty Python. Okay, weird name, but he was a fan of that, and therefore he named as after his name, called Python. Okay, so we discussed the advantages of Python, the advantages of being an interpreter, the advantages of why it is a multi-paradigm, what are the different uses of Python. So therefore there is a need for Python, right? So we see that the utility of Python is increasing day by day. So many giant IT companies are using Python more and more, right? And so there will be more and more jobs in this sector soon. So we have, more jobs. There is a lot more need now to learn Python than any time before, right? So other than that, what are the other advantages, or we can see, what are the other advantages of using Python? So we can classify them in several categories. So first of all, software quality. So why software quality? See, the Python code by design is readable, right? It's indented. Indentation is kind of forced inside Python, okay? And of course, we have functions for oops, modular, and so on. So, right? So it has all the features that provide a good quality software, right? And developer productivity, right? Why? It's quick to learn and build. It has lots of libraries giving helpful functions, right, at the tips of the developers, okay? So, and usually, the program is small. The program in Python that you write is much smaller than corresponding program in C or C++. So, for example, say, so let us see an example. Say we have to write a program to find how many unique numbers in an array, right? So if I have to find how many unique numbers in an array, so in C, what would you do, right? So we will have an order of n square algorithm, right? So we will have a for loop for I is equal to 0, I less than n, I plus plus, right? And then we have, say, k is equal to a of I, and then for j is equal to I plus 1, j less than n, j plus plus. If a of j is equal to k, then we break, right? And we have our count is equal to 0, and then we check if j is equal to n, then count plus plus, right? Because if this loop broke here using break statement, then that means that element was repeated. So that was my C program. Whereas in Python, I could have simply written length of set of A. Okay, so that's just one line program in Python. The set A is taking my array and converting into a set, and we know that set is a collection of unique elements. So set automatically finds all the unique elements in that array, and I am just printing the length of that set. We will look about that later, but you can see the difference between Python and C programming language, right? And next advantage of Python is that the program is portable, and we discussed it when the benefits of being interpreted. So as long as we have the interpreter anywhere, we can run the same program on any platform anywhere, okay? And as we also already discussed, it has bunch of support libraries in every domain. Consider it to be web or data science or text or GUI. So it has many applications, many support libraries, and the community is growing and growing and growing. And finally, there is wonderful support for component integration, right? So you can include C or C++ or Java program module inside of Python. Okay, details we will look at it later if necessary. All right. So this is the advantages. That's why Python is very much needed, and it's growing in the community more and more. And finally, we can actually see Python is very easy to learn and use, okay? Plus it is free because it's open source. So that's our introduction of Python. So I think now you can go through the detailed notes that are given to you, and you can make more sense of them. Okay, if you have any questions, let me know. Thank you.